All right, y'all, we are looking right now at the Polynomial Basics test review. Okay, there are a total of 20 questions. I don't know how long this is going to take. I'm hoping not too much. Okay, so the first problem is multiplying negative 3x squared times that polynomial that's inside of the parentheses right there. Okay, this is a very basic problem. If you're just multiplying, that just means you're distributing to the stuff inside the parentheses right there. Okay, your coefficients, make it positive 15. We've got x to the fourth. And then with your coefficients would make it negative 6, and that would be x to the fifth. But wait, we're not finished because this problem is asking us to do it in standard form. Okay, standard form, you got to remember that means we're going from larger exponents down to smaller exponents. So what we're going to actually do for our final answer is take that answer that we just got. We're going to swap the order of the terms so that x to the fifth comes first. Negative 6x to the fifth is first, plus 15x to the fourth. Problem number two. Problem number two is asking us to factor. We've got c cubed minus 729. What I'm noticing is that this is a difference of perfect cubes. Okay, we already know that c cubed is, that's c times c times c, right? So it's c cubed. If you take the cube root of that, it is c. Okay, so that's one of the things that we're going to be working with in our answer here is c. And we also know that the cube root of 729, is 9. So the two things that we're going to be getting when we're following that factoring pattern, when we're following the factoring pattern for a sum or difference of cubes, the two things that we're using are c and 9. Okay, so our first set of parentheses, the smaller one, is going to have c and 9. The second larger set is going to be c squared, 9c, and then 9 squared at the end. That's 81. Okay, and then for the plus and minus signs that connect all of this together, we're going to go same, opposite, always positive. Okay, so the first one, the small set of parentheses, is going to be the same as our original. Same. The second one, in between c squared and 9c, will be the opposite. So that's a plus. And then the last one is always positive. That's what that SOAP means, okay? And you're going to be able to use your notes when we take this test. So don't worry about that. If you can't necessarily keep track of what goes in these parentheses, okay, just remember that you're looking for the cube roots, okay? And then follow the examples that we did in the notes. Problem number three, we're subtracting polynomials, okay? Once again, this should not take too terribly long, except something to watch for right now would be making sure we distribute this negative to everything in the second set of parentheses right there, okay? So I'm just going to rewrite the whole thing, 9x squared, 6y squared plus 3. And now I'm going to rewrite the second set with the negative already distributed. So it'll be negative 10x squared plus 6y squared plus 4. Okay, and then the name of the game is just combining like terms. Okay, I'll do the x's first, and then the y's, and then the constants. Okay, let's see. 9 minus 10 with the x squareds would be negative 1 x squared. We've used both of those. The two 6y squareds are both being added, so plus 12y squared. And then our two constants would add together and make plus 7. Same thing on problem number 4. We need to remember to distribute that negative to everything inside the second set. X squared minus 64 remains the same, but now we're going minus x squared plus 16x minus 64. Okay, what I'm seeing first is that x squared and minus x squared, those two things cancel each other out completely. But now we've got plus 16x. That one's all by itself, doesn't have anything to combine with. Minus 64 and minus 64 would make it minus 128 when we've combined everything. All right, number 5, we actually get into some multiplication instead of just adding and subtracting. Number 5, what I'm going to do, you can, if you are comfortable with it, you're comfortable enough in your own math skills, you can just distribute. Send this x right there and there and there, then send the 3 right there to all three of the second set of parentheses. That's fine with me. If you're up for doing that, then go for it. Me personally, I like to use the box because it's so nicely organized and it makes sure that we don't forget anything. Okay, so I'm going to draw myself a 2 by 3 box. We've got 3x cubed for a 3-term one, 3x and plus 4 at the end. For going down the side, we've got x and plus 3. Okay, and we're just going to multiply everything that lines up in that grid. Something to watch out for as you're doing this would be like terms. Okay, be careful. Be on the lookout for any like terms that you would need to combine, such as these two right here. Okay, those two that I just circled. When we write down our final answer, we need to make sure we put those together. So I've got 3x to the fourth 9 plus 9x cubed, and then plus 3x squared. Then we combine our two like terms for 7x, and then plus 12 at the end. Up next on number 6, we are once again adding. Okay, once again, be careful because when you're adding, all you're doing is combining like terms, but these are not in the same order. You notice that the x's, one's at the beginning, one's in the middle. Okay, same with your y's, one's in the middle, one's at the end, and your z's. Okay, you can only combine like terms, right? Don't fly through this and misread something. Okay, it's real easy to do. We combine the x's, would be a positive 3x. The y's, let's see, that would be negative 7 minus 6, so minus 13y. And then minus 3 plus 7 would be plus 4z. Everything all put together there. All right, number 7 looks like it's going to be super duper challenging, but honestly, it's really not. Okay, it's much easier than it looks like if you can keep in mind that you need to have a greatest common factor drawn out at the beginning. Okay, because I look at all three of these coefficients, 6 and 60 and 144. Every single one of those is divisible by 6. Okay, so I'm going to draw out 6 as a greatest common factor at the front. And I also notice that they all have at least one x attached. So I'm going to draw out that to the front too. And look at what's left. After you divide out 6x as a greatest common factor, you've got minus 10x and then plus 24. And all of a sudden, this thing right here, all of a sudden is one of the easy type of quadratics that you would have to factor, right? This all of a sudden has become just one of those things where you're looking for two numbers that make a product of 24 and you add together to a sum of negative 10. Well, just a little, thinking about that for half a second, it's got to be negative 6 and negative 4. Okay, your two numbers, when I'm looking at that, what's circled right there, that multiply to 24 and add up to a sum of negative 10 would be negative 6 and negative 4 is your two numbers. So what I can do is I can convert that thing that I wrote down at the beginning for our final answer. We've got 6x. That's still going to be out at the front. But now we've got x minus 6 and x minus 4. So we end up with 3 different factors right there. For our final answer, we end up with 3 factors instead of just the 2. All right. Number 8. That is going to be a slip and slide type of problem. And you can already tell that the numbers are going to get pretty large. Okay. So let's do that. Send the 3 down to the end. Okay. Make it x squared plus 26x plus 105 when you multiply 3 times 35. So once again, we are looking for 2 very important key numbers, right? These numbers are going to multiply to 105. And when we add them together, it gives us a sum of 26. Okay, I'm going to save you a little time. Those two numbers are positive 21 and positive 5. Okay, 21 times 5 gives us this 105. 21 plus 5 gives us our 26. So that means this blue polynomial, this modified version of it, the modified version breaks down into x plus 21 times x plus 5. Well, don't forget that in our original, we sent this 3 down here and multiplied it. So to undo that and get back to our original, we have to divide it. We have to undo that by dividing. So what I'm going to do is I'm going to try and divide by 3, both of those numbers. This first one goes evenly. I'm going to go ahead and put my answer on the other side of our key numbers over here, okay? That first one, when you divide 21 by 3, that gives us x plus 7, okay? But this second one does not divide evenly. 5 over 3 does not divide evenly. So what do? I take my 3 and I plop it right back up here. I slide it right back in front of the x. And I turn that second factor into 3x plus 5. And there's my answer right there. Number 9, a square has a side that is length 5x minus 11. So the thing you need to remember about a square, okay, throwing it back to geometry for a second, a square has 4 sides. All of them are the same length, right? So if you're talking about the side length of 5x minus 11, all 4 sides are the same 5x minus 11. So if you're looking for the perimeter, all you got to do is multiply 4 times that side length. 4 times 5x minus 11. Okay, we do a little quick distribution. Turn that into 20x minus 44. Boom, there's your perimeter. On the other hand, your area can get a little bit more complicated because now we got to know the area of a square is side length times side length, right? So what we're really doing for area is 5x minus 11 times itself. Okay, you can draw yourself a box or you can just use foil. I'm going to go real quick here and just use foil. Okay, that area is going to be equal to 25x squared. Outer times outer minus 55x. Minus 55x again for the inner. And then last would be plus 121. I'm looking at the middle right here and I see like terms that can be combined. So my final answer for that one, I'll put 25x squared minus 110x plus 121. That's my area. Side length times side length right there. Number 10. Number 10 is a straight up factoring problem, and we're just doing a difference of 2 squares. We've got 9x squared. Okay, we know that 9x squared, if we took the square root of that, the square root of 9 is 3, square root of x squared is x. Boom, 3x. On the other term, we've got 16, and the square root of that, of course, is equal to 4. We already knew that. So that means when we factor this out, we're going to use that pattern where both of our factors are going to have a 3x, and both are also going to have a 4. One is adding, one is subtracting. Boom, we're done. We did it. We're halfway there, y'all. Power on through to number 11. Zach wrote a formula for the volume of a rectangular prism. Find the product. Y'all, this is 3 sentences that's asking you to just multiply what is on the screen right now. We're just going to multiply these 3 things all together. That's all we're trying to do. Okay? So here's what I'm going to do. I'm going to start with just the first 2. I'm going to start with just what I highlighted right there. Okay? W times W minus 1, we're going to turn that into W squared minus W. Easy peasy. But now we have that thing that is highlighted. We have it still needs to be multiplied again times what's highlighted in green. Times 5W plus 4. Okay? So if we multiply that now, we can use foil, we can use a box. I'll go ahead and draw a box. Okay, we've got W squared minus W. We've got 5W and positive 4. So that would be 5W cubed, negative 5W squared, 4W squared, and minus 4W. Okay, don't forget about combining your like terms that are highlighted in green right there. Don't forget about those. When we put it all together, I've got 5w cubed minus 1w squared minus 5 plus 4, right? Minus 5 and positive 4 there. And then at the end, minus 4w. Factoring once again. 12, 13, and 14 are all just factoring. Okay? So I'm looking for my two key numbers. Once again, I'm looking for my two key numbers that are going to multiply and give me a product of 40 and add together to give me a sum of 13. Y'all, we can get this quick and easy if you just use that multiplication chart, use a little bit of number sense. Your two numbers are 8 and 5. That's going to factor down into x plus 8 times x plus 5. Boom. Dunzo. Go on to the next one. The next one, we got to use that slip and slide method. Okay, I'm going to take my 16, send it down to the end. And really, the only reason I'm using slip and slide is because I look at these factors right here. I'm looking at the coefficients, 16 and 40 and 25. Unfortunately for us, there is not a single greatest common factor that we can divide from all three of those. We have to send the 16 to the end. We'll rewrite it, x squared plus 40x plus, and 16 times 25, got my calculator off to the side over here, 400. Good gracious, 400. All right, so we just need to think about what number could we multiply that would get us to 400, that would add up to 40. Now, you may or may not already know this, but 400 is actually a perfect square. 400 is 20 times 20. So if we're looking two numbers, or if we are looking for two numbers that multiply, give us a product of 400 and add to a sum of 40, it's 20 and 20. 20 times 20 is 400. 20 plus 20, of course, is 40. So this modified version right here, the modified polynomial, is x plus 20 and x plus 20. Well, here's the deal. Okay, x plus 20 and x plus 20, we still have to divide back this guy. Okay, don't forget about this last step. We slipped him down to the end. Okay, we multiplied it at the beginning. We have to divide it to put it back, right? So I'm going to try and divide by 16. Now, unfortunately, it does not divide evenly, but what we can do is reduce these fractions. Okay, what I'm going to do is I'm going to reduce these fractions, and even if you don't know how to do that off the top of your head, your calculator can do it for you. If you type in 20 divided by 16, hit enter, and then hit math frac, that will give you the fraction, which is 5 over 4, and that's how I'm going to rewrite this. Okay, I'm going to send it over to the other side of our two key numbers again. Okay, what that does, it turns into x plus 5 over 4 for both of them. 5 over 4, 5/4. Okay, and since neither of them divide evenly, we gotta slide these guys out in front of the x. What we end up with is two of the same factor. It's 4x plus 5 times 4x plus 5. Problem number 14. Problem number 14, if you are looking at a list of perfect cubes, you will recognize both 8 and 125 on that list. Okay, if we've got 8c cubed, that is the same thing as 2c whole thing cubed. Same thing with 125, that is 5 cubed. Since we've got two perfect cubes right there, that means 2c and 5. I'll go ahead and I'm going to put those off to the side a little bit. 2c and 5 are the two things that we're working with when we put it into the pattern. Okay, so your small set of parentheses has just that. It has 2c and it has 5. Your larger set is where you start squaring stuff, right? 2c squared would be 4c squared. And then you multiply the two things together. We would have 10c. And then at the end, you got 5 squared, which is 25. Okay? For our plus and minus, we go SOAP, right? Same, opposite, always positive. So we'll go same, opposite, always positive. And there we go. Problem number 15. Write the expression as a polynomial in standard form. Okay, this is another multiplication problem, kind of like we had way back at number 1. Y'all remember number 1? It's so long ago, wasn't it? We're going to multiply that out and then put it into standard form. Okay, so I'll draw myself a box just to make sure we're not missing anything. It's a good visual representation of what we're doing also. Okay, we'll have 7x plus 4. We'll have x minus 5 and multiply it all out. I'll use a different color for the middle there. X. Okay. Don't forget about combining like terms. These two guys right here are both just single x's. 7x squared. Let's see, those two combined is going to be minus, let's see, that'd be minus 31x and then minus 20 there at the end. Okay, in standard form, make sure you're going x squared first, and then the x, and then the constant at the end. Number 16, adding polynomials, the name of the game is like terms. Okay, I'm looking at a to the 5th and a to the 5th. And then I'm looking at a to the 4th, doesn't have anything else to combine with. I look at a cubed, couple things to combine there. I look next at my single a's. Minus 4 plus 11 would give me plus 7a. And then constants, just at the very end, plus 5 and minus 9 gives me minus 4, and that's my answer, everything put together. Makes a nice little list of colors going off right there, isn't it? All right, number 17. Number 17, I want to do my best right here to take out a greatest common factor because I notice that all three of these terms have an x in them. Okay, so I'm going to divide that out at the very beginning. If we divide out one of the x's, what do we have left? X squared, 2x, and just 15 all alone by itself. So we're looking for two numbers that will multiply and give us negative 15. They will add together for a sum of 2. Product of negative 15, sum of 2. Okay, 15, you got to think is 1 times 15 or 5 times 3, right? So we just need the combination of positive and negative that when we combine gives us positive 2. I'm thinking it's going to be plus 5 and minus 3. So for our final answer, we put it all together. We've got x out front. We've got x plus 5. We've got x minus 3. Number 18, once again, check for a greatest common factor. Both of those numbers could be divided. First thing I noticed is that both of them are negative, right? So we can both divide them by a negative, and we can divide both of those coefficients by 3. And both of our terms also have at least one x. So if I divide all of that stuff out at the same time, I'm left with 5x, and I'm left with 7. Dividing out the negative turns both of those things inside into positives, doesn't it? All right, number 19 and 20 are a little bit different because they're asking what formula should be used. Okay, the formula that should be used, what it's talking about is the specific formula that is in your notes. Okay, you notice that both of these are perfect cubes and they're being added together. So the sum formula, remember if you're working with a cubed plus b cubed, you've got a small set of parentheses, you've got a large set of parentheses, a squared, a times b, b squared, okay? And your plus and minus signs use SOAP. Same, opposite, always positive at the end, okay? That's what the formula is. Now, we know that if we were doing this problem for real, a and b would be replaced with x and 3, okay? It would be x plus 3, and then x squared, 3x, and 9, okay? But this problem was just asking for the formula. Same thing on number 20. Same thing on number 20. We can see that on this particular problem, we would have to take out a GCF first, okay, turn it into 2x cubed minus 125. But we also know that x cubed and 125 are both perfect cubes. So we'd be using this same formula, okay, the same formula. We would still have a and b. We would still have a squared, a times b, and b squared. But now our symbols would go same, opposite, always positive. It's okay. So it's the same. It's the same abbreviation, SOAP, except this time when we go same, opposite, always positive, we're using this one from the original. Same, opposite, always positive there at the end. Okay, so that's the formula we would be using. This time it would be minus plus plus instead of plus minus plus. All right. That's all we've got for the test review. I sincerely hope that everybody got these answers. And if you didn't, then scroll back and watch it, okay? Because you're allowed to use this test when you take, you're allowed to use this review when you actually take the test, okay? Use your notes, use your review, and study up real good, all right? That's all we've got for now. Y'all have a good one.